Hello friends, welcome to VTech Academy. In our previous video, we have proved the standard binomial expansion for 1 plus x whole power n is equal to c0 plus c1x plus c2x square plus so on plus cn x power n. So here in this presentation, let us prove some important properties with this standard notation. So first let us consider this as equation 1, and now let us substitute x is equal to 1 in the equation 1. So we get here 1 plus 1 whole power n is equal to c0 plus c1 into 1 plus c2 into 1 square plus so on plus cn into 1 power n. That implies we get here c0 plus c1 plus c2 plus so on plus cn is equal to 1 plus 1 whole power n would come as 2 power n. Now let us consider this as equation 2. And now let us substitute x is equal to minus 1 in equation 1. So on substituting we get here 1 minus 1 whole power n is equal to c0 plus c1 into minus 1 plus c2 into minus 1 whole square plus so on plus cn into minus 1 whole power n. That implies we get here c0 plus c1 into minus 1 would come as minus c1 plus c2 plus so on plus minus 1 whole power n into cn is equal to 1 minus 1 whole power n would come as 0 power n, which is nothing but 0. Now let us consider this as equation 3. And now let us add the equation 2 and 3. So on adding we get here c0 plus c1 plus c2 plus c3 plus so on plus cn is equal to 2 power n, and the equation 3 is c0 minus c1 plus c2 minus c3 plus so on minus 1 whole power n cn is equal to 0. Now let us add these both equations. We observe that c1 and minus c1 and c3 and minus c3 get cancelled, and by adding the remaining terms we get c0 plus c0 as 2c0 and c2 plus c2 would come as 2c2 plus so on. Coming over to the nth term, by adding we get here cn plus minus 1 whole power n cn is equal to 2 power n. Now let us take 2 as a common factor from the left hand side of the equation. So we get here 2 into c0 plus c2 plus so on plus, and here by taking cn as a common factor we get here 1 plus minus 1 whole power n divided by 2 into cn is equal to 2 power n. Now let us transfer 2 to the other side. We get here c0 plus c2 plus so on 1 plus minus 1 whole power n divided by 2 into cn is equal to 2 power n divided by 2. So this would come as 2 power n, and we know that here 1 by a can be written as a power minus 1. So by applying this formula, we can write here 1 by 2 as 2 power minus 1. So here we observe that the bases are equal. So on adding the powers, we get here 2 power n minus 1. Now let us say if n is an even number, then we get this equation as c0 plus c2 plus so on. And now let us simplify the nth term. So we get here 1 plus minus 1 whole power n. If n is an even number, then its value would be 1. So we get here 1 plus 1 divided by 2 is equal to 2 divided by 2. On simplifying, 2 and 2 get cancelled and we get here value as 1. So 1 into cn would come as cn is equal to 2 power n minus 1. And now let us say if n is an odd number, then we get this as c0 plus c2 plus so on, and the nth term would be 1 plus, as here n is odd, we get here minus 1 divided by 2 is equal to 1 minus 1 divided by 2. So this would come as 0 divided by 2, and we know that its value is 0. So as here the coefficient of cn is 0, we don't have here cn term. So let us consider the previous term of cn, which is nothing but cn minus 1 is equal to 2 power n minus 1. So these were the two important properties of the standard binomial theorem. That is, if n is an even number, then c0 plus c2 plus so on plus cn is equal to 2 power n minus 1, and if n is an odd number, then c0 plus c2 plus so on plus cn minus 1 is equal to 2 power n minus 1. So this is how we prove the important properties of the standard binomial theorem. Hope you understood the concept. Refer to more videos on binomial theorem on our website vtechacademy.com. Thanks for watching. Till then, have a nice day.